In this video, I will show you how to solve polynomial inequalities such as this one. Your first step is to get 0 on one side. So I am going to subtract x from both sides. So look, so far that just gives me x to the third power, because these both cancel out, don't they? So that's x to the third power is less than or equal to 1. So now I'm going to subtract 1 from both sides. So that gives me x to the third power minus 1 is less than or equal to 0. So once you have 0 on one side, this is the version of the inequality that we will be looking at for the rest of this problem. But to solve this inequality, we need to start by solving the related equation, x to the third power minus 1 is equal to 0. Okay, so we need to, in other words, find the zeros of this function, because those will form the boundary points of our solution set. Okay, so how do I solve this equation? Well, one thing I could do is I can add 1 to both sides. Alright, I'm going to add 1 here and here. So that's going to give me x to the third power is equal to 1. Then I'm going to take the cube root of both sides. Alright, if I want to uncube something, that's going to be the cube root of both sides. Okay, so that's going to give me x is equal to 1. So that is my only real 0 here. Okay, so that's going to be my one value that I'm going to graph on my number line. So let's go ahead and make the number line. And okay, here's 1. So I'm going to plot a boundary point right there. So the question is, should this be a closed circle or an open circle? Well, this is a value where the function is equal to 0. The solutions are going to be values where the function is less than or equal to 0. So we want to include the points where the function is equal to 0 because of the or equal to part of this statement. So to show that this will be part of the solution, we will make it a closed circle. So look, in other words, if you have or equal to, then it's going to be a closed circle. If this had just been less than, then I would have left it an open circle. Anyway, this boundary point here divides the number line up into two intervals. Okay, we have this interval to the left and we have this interval to the right. So to the left, we need a value that is a test value that is less than 1. Well, 0 would be a good value to use. Remember, looking at this version of the inequality, solutions are going to be values that cause the function to be less than or equal to 0. So we want to know at 0, is the function less than or equal to 0? Alright, we need another test value in this interval that is greater than 1. So why not? Let's just pick 2. And again, we will ask ourselves, is the function less than or equal to 0 at this value? So I am going to use my TI-30XS multiview to help me out. Even though this function is so simple, I really could do it by hand. Maybe I'll do it both ways real quick. Okay, so looking at the left side of this inequality, x to the third power minus 1. So I could hit my table function and type this in, x to the third power minus 1. Okay, I could do it this way. I'm going to stick with ask x as I do this. So here are the two values at which we want to evaluate, 0 and 2. Oh, those are two values that happen to be already in here. But if they weren't, you would just type in 0 and 2 like that. So we get the y values that go with them, all right, -1 and 7. Okay, so here we have -1 and here we have 7. And the question is this less than or equal to 0? Well, yes it is. -1 is less than 0. Okay, that means 0 is a solution. That means everything over here to the left is going to be a solution. So I will show that by putting an array representing these solutions. Now here I got 7. Is 7 less than or equal to 0? Well, of course not. That's just silly. That means 2 is not a solution, which means none of the values in this interval will be solutions. So we'll just leave that blank. So rewriting this graph in interval notation, the solutions come from -infinity up to 1. And I will use a square bracket to show that the point 1 is included as part of the solution set. Alright, so this is the solution in interval notation. Now I used my calculator to find to evaluate the function at 0 and 2. But let me just show you real quick how I could have easily done it by hand. So the function that we were evaluating is x to the third power minus 1. Okay, so just keep that in mind. So we're talking about x to the third power minus 1 here, and whether or not it's less than or equal to 0. So if x is 0, then this becomes 0 to the third power minus 1. And is that less than or equal to 0? Well, of course, 0 to the third power is just 0. Okay, and 0 minus 1 is just -1. Okay, so which is exactly what we had, but we could have done it by hand. And same thing over here with 2. Again, we're talking about the function x to the third power minus 1. So if I let x be 2, then I'd be talking about 2 to the third power minus 1. Is that less than or equal to 0? Well, 2 to the third power is 8. Okay, and 8 minus 1 is 7. Okay, so we could have done this by hand and it would have been the same thing. Alright, but for now, let's move on to problem number 4. So, to solve this inequality, I recommend getting 0 on one side. So I would subtract x from both sides first. So this is going to give us x to the third power minus 4x is less than or equal to 0. Okay, now this is the version of the inequality that we will deal with for the rest of this problem. You can pretty much forget about the original problem from this point forward. Okay, now to solve this inequality, we need to find the zeros of the function. So in other words, we need to solve the related equation x to the third power minus 4x is equal to 0. This will give us the boundary points of our solution set. So how am I going to solve this equation? Well, this is factorable, and the first step of factoring is to take out the common factor, the GCF. So if I take out x, alright, then that's going to leave behind x squared minus 4. Alright, now this can be factored further as the difference of two squares. So x squared minus 4 factors as x plus 2, x minus 2. Okay, so notice I have 3 factors here. Do not ignore the x. A lot of kids forget about the x. So we need to set each of these equal to 0. So including the x. So x equals 0, x plus 2 equals 0, x minus 2 is equal to 0. So this is one of the zeros right here. Solving this is going to give me x equals -2. That's another 0. Solving this is going to give me x equals positive 2. That's another 0. So these are the 3 zeros that I need to graph on my number line. Alright, let's see. So negative 2, 0, and positive 2, if I put them kind of in order. So here we go. Here's my number line. So what did I say? Negative 2, 0, and positive 2. So these are my boundary points. Should these be open circles or closed circles? Well, because this the solutions can be less than or equal to 0, and these are the places where the function is equal to 0. These are solutions. Alright, equal to 0 is okay. So we will show that these are included by making these closed circles. So look, these boundary points divide the number line up into 4 intervals. We need a test value in each one of these intervals. So we need a test value that is less than negative 2. So why not negative 3? Now let's keep in mind what constitutes a solution. So looking back at this version of the inequality, solutions will be where the function is less than or equal to 0. So each time we're going to ask ourselves, will the function be less than or equal to 0 here? Alright, we need a test value between negative 2 and 0. The obvious choice here is negative 1. Will the function be less than or equal to 0 here? How about between 0 and 2? The obvious choice is positive 1. Will the function be less than or equal to 0 here? And then we need a test value greater than 2. So how about 3? Will the function be less than or equal to 0 here? Alright, I am definitely going to use my TI-30XS multiview to help me test the function at these test values. So I'm going to type in the left side of the function into my calculator. So hit the table feature. Alright, and we have x to the third power minus 4x. Okay, so I've got x to the third power, and you could type that in, and then minus 4x. Okay, we're going to leave it in Ask X mode. Alright, make sure it is in Ask X mode, not auto. Alright, we can only do 3 values at a time, and we've got 4 values that need to be checked. So I'm going to do 2 and 2. So let's start with negative 3 and negative 1. Okay, so here's negative 3 and here's negative 1. So that's negative 15 and 3. So I have negative 15 and 3. And the question is, are these less than or equal to 0? Well, negative 15 is less than or equal to 0. That means negative 3 is a solution, which means that every value in this interval is a solution. We will show that by drawing a ray in this interval. Is 3 less than or equal to 0? No, it is not. That means negative 1 is not a solution. That means none of these values in this interval will be solutions. Okay, now let's check 1 and positive 3. Okay, so I'm just going to go back and change these to 1 and 3. So that's negative 3 and 15. So this is negative 3 and 15. And again, we're asking if the function is less than or equal to 0. And we have another yes! Negative 3 is less than or equal to 0. That means 1 is a solution. That means all of the points in this interval will be solutions. Is 15 less than or equal to 0? No. So that means 3 is not a solution, which means none of the values in this interval will be solutions. So we have these two intervals full of solutions. So this first interval, in interval notation, we would write negative infinity to negative 2. And we'll put a bracket on it. Negative infinity to negative 2. Bracket means include the negative 2. See the closed circle? Now this interval from 0 to 2. So I'm going to put bracket 0 to 2. Close bracket. Include, include. When you have an interval that's in two separate parts, you will join them together with a union symbol, meaning this is really one solution set. So this would be your answer in interval notation. That's going to do it for this video. I have a couple more problems to do, but I'm going to go ahead and throw them on the next video. So I'll see you over there.